Hi everyone, I'm Ravi. Today we will see how to calculate standardized precipitation index. Firstly, I will describe the mathematical equations. Later, I will show how to calculate SPI in an Excel sheet using the same mathematical steps. So, SPI is equal to normal inverse of this particular equation, Q plus 1 minus Q multiplied by cumulative probability. So, in this equation, we should know what is Q and what is cumulative probability. So cumulative probability is a function of precipitation observation, comma alpha, comma beta, right? And Q is equal to M by N, where M is equal to number of zero observations and N is equal to total number of observations. So here we will derive the cumulative probability using a gamma distribution function. So why gamma distribution? There has been a lot of research and World Meteorological Organization WMO has recommended to use gamma distribution for deriving SPI. So to calculate cumulative probability, we need to know what is alpha and what is beta, right? So the unknown parameters in this equation is the alpha and beta. So beta is equal to average by alpha. Alpha is equal to 1 by 4a plus 1 plus square root of 1 plus 4a by 3, right? So we will see firstly how to calculate alpha. Once alpha is calculated, we will see how to calculate beta. So to calculate alpha, we need to know what is A in this equation. So A is equal to ln of average of non-zero precipitation observations. For example, if we have 30 monthly precipitation values of January, in that particular out of 30, if we have say 12 non-zero observations and 18 zero observations, now we need to calculate the average for the non-zero precipitation values. Okay, so this average should be calculated for the 12 values. So ln of x bar minus summation of I is equal to 1 is to capital N. So here capital N represents number of non-zero precipitation observations. So we have 12. For example, we have 12. So I runs from 1 to 12. Ln of each day precipitation value, right? Divided by 12. So firstly, we need to calculate the average of non-zero precipitation observations and then calculate A, capital A. That capital A, if we replace here, we will get the alpha. Once alpha is determined, we can then determine the beta. Beta is equal to x bar, which is average of non-zero precipitation observations divided by alpha. Okay. So if we know alpha and beta, we can then use this gamma distribution and then we can calculate the cumulative probability. Once the cumulative probability is derived, we can use that cumulative probability in this equation. And we need to calculate what is Q. So Q is equal to small m by small n. So small m, number of zero observations, that is 18. And small n, total number of observations, that is 30. So Q is equal to 18 by 30. Okay. So standardized precipitation index is equal to normal inverse of this equation. So firstly, we will calculate what is cumulative probability and then Q. So to calculate cumulative probability, we need to find a distribution parameters, that is alpha and beta. So to calculate alpha, we need to calculate capital A. So to calculate capital A, we need to identify firstly how many non-zero observations are there, and then make average out of it. So x bar, and then using this equation, we'll find the alpha. Using alpha, we'll find the beta, and then the cumulative probability, and then the SPI. So we will replicate the same steps in an Excel sheet. So firstly, we need to take the data. So for this demonstration, I have considered monthly precipitation from the year 1981 to 2010 for a particular station. So I'm just copying this data so that I'm starting from beginning. You can replicate it by following by repeating the same steps. So I've copied the data. Now what to do next? Select the 3 columns, go to filter, click on filter. Next, select the month. Small, so you can untick select all, and then select first month, January. Okay. Right, open on another sheet and type, for example, in this way. Type P1, P2, P3, P4, so on up to P12. So first month precipitation, second month precipitation, third month precipitation, fourth month precipitation, fifth month, and so on up to 12th month precipitation. Okay. So I'll just copy these things, copy, and I'll paste it here. Okay. So my first month precipitation, shift control down arrow, control C, go to sheet 2, paste the values. Okay. And then repeat the same process for the second month now. 2. Now you get the values for the second month. Control C, second sheet, P2. Okay. Great. Now repeat the same steps for every month. So 3, control C, go to sheet 2, paste it here. 4, control C, P4, and then, so I'm just copying from the another Excel sheet which are the same values. So P5 to P12. Okay. Now we have the monthly time series. So we converted column vector. We have the column vector. We converted that column vector into a matrix, right? So first month, second month till last month. So 30 observations. As I told to you, we need to identify non-zero precipitation observations. Non-zero precipitation observations. So retain the non-zero values. Step 2. Control C. Pasting it here. Step 2. We need to identify the non-zero observations for all the 12 months. Next. So Control C. Paste it here. These are 0 observations. Let me put in this way. So I'm choosing 2 decimals. So these are 0 observations. And I have these 2 values again. Paste it here. and then zeros. I have 1.2, 4.34, 0.29, 0.91, 1, and then 1. Copy these values and then paste it here. Yeah. So in a similar way, you can replicate the process for the remaining months. So we can select this entire month and then unselect zeros from it. Zeros. So get rid of zeros and then copy the non-zero observations and paste it here. Right? So I am using my existing sheet and copying the remaining things. Yes. So now we have achieved step 2, retain the non-zero values. Okay. What's our step 3 now? So now we have the non-zero precipitation observations. Our first step is to calculate ln of x, individual logarithm of x. So step 3, calculate the natural logarithm of each precipitation observation. Step 3. I'm placing it here. Step 3. Now we need to calculate natural logarithm. So how to calculate natural logarithm? Simply is equal to ln, open bracket, select the observation and then close it. So you can drag the values. So how many? So num means there's no value here. So delete. And here, if you drag in a right side way, so now you can see R4, which is R4 means this particular value. So second month, third month, fourth month, fifth month, so on up to 12th month. Now drag the values and you can find num. So there are no values. Delete. In a similar way, drag the values. Okay, so I think still if we go, okay, delete. So you can see whether there are 30 observations here. Okay, only 28. That means 2 are 0 observations. So yeah, let me re-verify how many values we have here. So this is the first month, second month, third month, 28 values, right? Now we are in the fourth month. So 1, 2, 3, but here we are missing some values. I think I haven't copied correctly. Yeah, I have missed these values. Control C. This is the fourth month, right? Yeah, fourth month, Control V. Yeah. Now drag the same. Great. So 30 observations. You can see the count here, count 30. So 30 observations. I mean, what's the meaning of 30 observations here? There are no zero observation, right? Or all are non-zero values in that particular month. Same for the fifth month. Now for the sixth month. For the sixth month, there's no value here. For the seventh month, yeah. Now for the eighth month, so we don't have values here. Ninth, so we don't have values here. Next, 10. Okay. Last month, 12th month. So in 12th month, out of 30 observations, we have only 3 non-zero precipitation values. Rest are zero precipitation values. So no precipitation at all. So we have calculated the natural logarithm of the precipitation observation, right? So now let us go back. So we have completed the natural logarithm of x, right? Now we will do the calculation of capital A. To do the capital A, we need to calculate firstly the average of non-zero precipitation observations. So that is step 4. So okay, step 3, and here we are step 4. So firstly, I'm calculating the average. Okay, average, which is equal to type average, and then you can see this function. Double click on it. So this is the starting number and this is the ending number. Or you can also drag till the end, yeah, till here, and then close it. So you got the average of the first month. Let me re-verify 0.01995. Oh, sorry. This is, I did a mistake, right? What is a mistake? I've calculated the average for the natural logarithm. That should not be done. So we should calculate the average for this particular values, right? So which is equal to average, double click, and then select the observation values. So which are 30. Yeah. Now you got 2.04. Let me re-verify. So 2.04. Right. And then drag the cell till 12 months. The count is 12. So 12 months. Right. So now you got the average of non-zero precipitation observations. Now you need to calculate the summation, right? Now you need to calculate the summation of natural logarithm values. So sum, which is equal to sum of natural logarithm, right? So this particular 30 observations. Yeah. So drag this for 12 months and you got the summation of, so let me re-verify once again. So minus 0.22 minus 1.08. Yeah, minus 0.22, almost like 19 is 22, and yeah, 5 is 8. So perfect. Now our aim is to calculate capital A, right? So capital A. Yeah. So now capital A. So what is the equation of capital A? So the equation of capital A is okay. So to derive the capital A, we need to identify the number of non-zero precipitation observations. So to get the non-zero, so here it is like capital N, non-zero precipitation observations, which is equal to say count, or yeah, counts the number of cells in a range that contain numbers, right? So count of non-zero observations. So these are the non-zero observations. I mean, I'm selecting 30 rows. Let us see what we will get. So we got 11, right? Out of 30 rows, we have 11 rows with precipitation values. And now I'm dragging it right side. So, okay. So I have 21 precipitation observations for February, 28 for March, 30 April, 30 May, so on, 3 for December. Now I need to calculate my A. So to calculate A, I'll go through the equation once again. Natural logarithm of algorithm. So natural logarithm, which is equal to natural logarithm of average value, average minus summation, right? This is the summation divided by capital N. So I'm keeping it in a closed bracket. Yeah, anyway. So natural logarithm of average. Natural logarithm of average minus, this is the summation, by capital N, number of non-zero observations. So ln of average minus summation by capital N. Now drag this for rest of the months. So we calculated capital A. What's the next step? We achieved A. Now we need to calculate alpha. So alpha. So alpha. Alpha is equal to 1 by 4a alpha is equal to, say, 1 by, I'll start with closing bracket, 1 by 4 times open bracket 4 times a, 1 by 4a, 1 by 4a. Now open bracket. So 1 by 4a is done. I'm deleting this bracket. 1 by 4a is done. Now we need to open a bracket. So 1 by 4a, so we can keep multiplication symbol, multiply, open bracket. Now 1 plus, so 1 plus, what we need to do? Square root of. So 1 plus square root of SQRT. If you type SQRT, we'll get the square root. So to calculate square root for what? Close bracket. Keep it in close bracket. 1 plus square root of 1 plus 4a by 3. So 4 multiplied by a by 3, 4a by 3. So I want this 4a by 3 in one bracket. So close bracket and open bracket. So 1 plus 4a by 3. 1 plus 4a by 3, I'll close the bracket. Good. If we have errors, it will show. So 1 by 4a multiplied by 1 plus square root of 1 plus 4a by 3, which is 0.82. So so we calculated alpha. Drag it for rest of the months. So now we got the alpha. Okay. Now what's the next step to find beta? Beta is equal to average by alpha. So this is average by alpha. Okay. So we got the beta value. Great. So successfully, let me recap. We identified the non-zero observations and we calculated the natural logarithm of each observation, and then we calculated the average, and then summation, and then capital A. Using capital A, we calculated alpha, and using alpha, we calculated beta. So our next step. So now we know the alpha and beta. Now we need to calculate cumulative probability. So cumulative probability is the gamma distribution. Using gamma distribution of the observation, comma, alpha, comma, beta. Right? So this observation, so let me do that. Now we need to calculate our cumulative probability. So cumulative probability is equal to what I told, gamma distribution, gamma dot distribution. we need to give our precipitation observation value, right? So here is our precipitation observation, comma, we need to provide the alpha value. So alpha, comma, beta. So here you can see it will give us a hint. What is our next? Beta, comma, true. True means cumulative distribution function. False means probability mass function. We need cumulative distribution function. True. And then close the bracket. Okay, so this is the cumulative probability of the first observation. So so now here the challenge is, in this particular equation, alpha and beta remains constant for that particular month and the observation should change. Okay, so to make this alpha and beta constant, I'm simply keeping a dollar symbol. $78, $80. So that now what we will do, if we drag these values, you can find 78, 78 remain constant. C5. C5 means second observation. Okay, this is C and this is 5. This is the second observation. So we need to go till C33. So 13, right? So we will extend it for say 30 observations. So 30 observations. Okay. So we calculated the cumulative probability. So if it is 0, that means there is no precipitation value. That is a non-zero precipitation. I mean, sorry, zero precipitation, zeros. Right. So we calculated the cumulative probability for the January. Right. So now we will extend the process for the remaining months. Now simply I will drag this. You will find an interesting observation, right? Now earlier it was Q, alpha and beta of Q, January. Now we need for the month of February, which is R. So R $78, R $80, right? Alpha and beta of February. And now earlier it was C, now it was D. So that's the advantage. Now simply double click on this. You will get the cumulative probability for February. Now simply extend the process till December. Right. So see here AB. AB means the alpha and beta of December. And we have the observations for December. So double click on it. And simply you can select the entire row and double click. So now you got the cumulative probability. So cumulative probability is very easy. Type gamma dot distribution and then provide the precipitation observation alpha comma beta. Okay. So this precipitation observation should be your entire 30 days vector. Sorry, 30 cells vector. If you have 60 monthly values, you can provide 60. If you have 15, you can provide 15. If you have 20, you can provide 20. Right? All the observations. Right. Now, I achieved my cumulative probability. There is one more parameter to calculate, that is Q. So Q is equal to small m by small n, which is 0 observations by total number of observations. So how to calculate small m? Simply, if I like from the total number of observations minus non-zero observations, then I'll get the 0 observations, right? So I know my non-zero observations is capital N. Capital N. So to calculate small m, I know total number of observations is small n. So small n minus capital N will give you m. So now I need to derive my Q. So I am calculating the Q here, which is equal to what I told total. Total is 30. I know 30 minus 30 minus here I've calculated capital N. Capital N keep this in close bracket, divided by 30, right? Yeah, so and then drag it for all the months. Great. Now I need to calculate my final uh, equation. So this is my final equation. So final equation, which is equal to simply Q, which is Q plus open bracket 1 minus Q multiplied by cumulative probability. So this is the cumulative probability. And then simply double click on it. Okay, so you can extend, yeah, for all the months and then drag it for 30 days. So 56. Okay, I did some mistake here. Okay, so dollar symbol is important. I missed the dollar symbol, right? So here, this Q should be constant. Q should be constant. Now I should do it for 30. So count 30. So similarly, here I'll drag this for the rest of the months. And from here, double click on it. So you'll get the values. Now, what we need to achieve the final task is to apply norm dot inverse of this, and then we'll get the SPI. So SPI, we are providing here SPI, and then which is equal to norm dot INV, normal inverse of this probability, comma 0. 0 mean with 1 standard deviation. So simply drag for all the months and then drag it for 30 days. Drag it for 30. So count is 23. Still, I need to go for, yeah, 30. And repeat the process for the rest of the months. Now, okay, this is the starting year to ending year. Starting year to ending year. And here we will insert one row, insert, shifts dwells down. So here I'll copy the months, January, February to December. Yeah. So finally we achieved the SPA values for the monthly data. So now here you can simply copy SPI here. And to simply do that, I told you to select filter. So filter, select the filter, and then select the month here, say select 1, and then copy this SPA values here of January. Copy and paste it here. Okay, so you can paste it like 1, 2, 3. Oh, only 3. Yeah, simply you can use this matrix for your calculations for understanding the SPA values. Yeah. So let me recap once again. From a given vector, from the monthly vector, identify non-zero observations for that respective month. January separately, February separately, March, so on up to December. And then calculate the average of non-zero observations, natural logarithm of each observation, and then do summation. And then calculate capital A. Using capital A, calculate alpha and then beta. Using alpha and beta, find the cumulative probability using gamma distribution and calculate small q, and then apply normal inverse, and thereby you will achieve the standardized precipitation index. Okay. So if you have any doubts in understanding, please let me know. Thank you.